Question 10 from Section 2 of the 2019 National 5 SQA exam. Infrared and gamma rays are both members of a family of waves. And for 1 mark we have to state the name given to this family of waves. Well, the name given to the family of waves are called the electromagnetic waves, and there's a picture of them there in that little poster. The key thing about electromagnetic waves is they all travel with the speed of 3 times 10 to the power 8 meters per second. In other words, the speed of light. So they've all got the same speed, providing they're travelling through the same medium. Now, for part B, for 1 mark, you're asked to state how the frequency of infrared compares to the frequency of gamma rays. And on the chart that you can see, if I square off the infrared section there, you can see it's got a frequency of 10 to the power 14 Hertz, which is really quite a high frequency. But if I compare that to gamma rays, you can see gamma rays have got a much higher frequency of 10 to the power 20 Hertz. So the frequency of gamma rays is much higher than the frequency of infrared waves. Question 10, part C. Some examples of sources and detectors of waves in this family are shown. And we know the family we're talking about is the electromagnetic wave family. We have a heater, we have a radioactive waste, we have a Geiger-Müller tube, we have an LED, which is a light emitting diode, we have a black bulb thermometer, that's an ordinary thermometer with the bulb at the bottom painted black, that's a clue, and then fluorescent ink. So which of these are sources and which of these are detectors? Well, we know right away that the heater is a source of heat, infrared radiation. The radioactive waste is a source of radioactivity. And the Geiger-Müller tube, well, that's a detector. That's going to detect radiation. The LED is a source of light. And the black bulb thermometer, well, that's a detector as well. And that's going to detect infrared radiation, as we'll see in the question. And then fluorescent ink, well, that can be considered as a detector as well. That's going to detect something which we'll talk about in a minute. So, to our question in part I, from the example shown, identify the detector of infrared radiation. The detector for infrared radiation is the black bulb thermometer. And the reason why it's black at the bottom, because black absorbs heat. And therefore you will detect infrared radiation if you place this thermometer near a source of heat. The black painted bulb at the bottom will absorb the heat all the more. So to detect infrared radiation, we'd use a black bulb thermometer. For I part B, it's asking you for the source of gamma rays, and the source of gamma rays, well, we know just looking at it, it must be radioactive waste. So radioactive waste would be the source of gamma rays, and of course that could be detected by a radioactive detector. Now part 2 says suggest one application for the waves that are detected using fluorescent ink. Now fluorescent ink is a very lovely material because it glows, and it glows in the presence of ultraviolet light. So if you have ultraviolet light, it can be detected with fluorescent ink. I'm going to show you a little movie of that right now, because you'll find out that if you have a special fluorescent pen, you can mark objects. Or if you look at some banknotes have got fluorescent ink printed on them, so you can't see them, but when you put ultraviolet light on them, you can see them. Here's the movie. So here we have our ultraviolet light. We have a £10 banknote, and if we flash the ultraviolet light on it, you can see that the small Scottish flag lights up. It fluoresces. There it goes again. You can see that when we put the light out, it disappears, and when you put light on, it appears because little ink in there fluoresces. Here we have someone's toolkit, and they can security mark it with the fluorescent pen. The mark on it, you don't see the ink, but when you shine the ultraviolet light on it, you will see quite clearly the writing stands out because the ink fluoresces. When the ultraviolet radiation lands on it, the ink fluoresces, which means it gives off light. There's a pen top taking off the pen here, and you can see how the nib of the felt tip pen, which is an ultraviolet marker, glows with the ink on the nib. So ultraviolet light detected by fluorescence.